Hey everyone, and welcome back to the channel. Today we re-diving into one of the most fundamental and fascinating components in all of electronics, the capacitor. You've probably seen these little cylindrical or disc-shaped things on circuit boards, but what do they actually do? Stick around because by the end of this video, you'll understand exactly how they work and why they're so incredibly important too. At its core, what is a capacitor? Think of it like a tiny, rechargeable battery that can charge and discharge almost instantly. Its main job is to store electrical energy. The simplest capacitor is made of two conductive plates, usually metal, separated by an insulating material called a dielectric. This dielectric can be anything from air to ceramic to plastic or even a special chemical paste. Here's the magic. When you connect a capacitor to a power source like a battery, positive charge builds up on one plate, and negative charge builds up on the other. An electric field is created in the dielectric between the plates. This field is where the energy is actually stored. The key thing to remember is that because of the insulating dielectric, the current doesn't actually flow through the capacitor. The charges just accumulate on the plates, waiting to be released. The amount of charge a capacitor can store is called its capacitance, and it's measured in a unit called farads, named after the scientist Michael Faraday. A 1 farad capacitor is actually huge, so in most electronics you'll see microfarads, nanofarads, or even picofarads. The capacitance depends on a few things. The size of the metal plates, bigger plates mean more capacitance. The distance between them, closer plates, also mean more capacitance. And the type of dielectric material used. So, what's the point of storing this energy? Well, capacitors have tons of applications because of their ability to charge and discharge quickly. One of the most common uses is in power supplies, where they act as filters. When you convert a C power from your wall outlet to the DC power your electronics need, the voltage isn't perfectly smooth, it has ripples. A capacitor smooths out these ripples by discharging when the voltage drops and charging when it rises, providing a steady, clean power source. Another great example is in a camera flash. Your camera battery can't release enough energy quickly enough to create that bright burst of light. So, it slowly charges a capacitor over a few seconds. When you press the shutter button, all that stored energy is dumped from the capacitor into the flash bulb in a fraction of a second, creating that intense flash. Pretty cool, right? Capacitors are also crucial in timing circuits. Paired with a resistor, a capacitor can create a delay. The time it takes for the capacitor to charge or discharge through the resistor can be precisely calculated, which is essential for things like blinking LEDs or creating the clock signal that runs your computer's processor. They're also used in audio equipment to block DC signals while letting audio signals pass through, and in radio tuners to select specific frequencies. So, from your smartphone and computer to your car and home appliances, these little energy storage devices are everywhere, quietly doing their job to make our technology work. They are the unsung heroes of modern electronics, smoothing power, timing events, and filtering signals. The next time you see a circuit board, take a closer look at those little cans and discs, and now you'll know the powerful secret they hold inside. I hope this helped you understand the basics of capacitors. If you found this video interesting or learned something new, give it a thumbs up and consider subscribing for more deep dives into the world of electronics. Have any questions? Drop them in the comments below. Thanks for watching, and I'll see you in the next one.